Welcome back everyone. In this session of automated theory and computability, let's solve few more problems on writing context-free grammar for the given context-free languages. Okay, here the first one, the language L is made up of string W, which is made up of alphabet symbols A and B, and the definition says A replicated n number of times, concatenated with B again is replicated n number of times, where n is greater than or equal to 0. Okay. So the constraint is all the A's should occur before B, and the number of A's should match with the number of B's. Okay, so I have to write the starting non-terminal S, and since n is greater than or equal to 0, what if n happens to be 0? Then number of A's will be equal to 0 and number of B will be equal to 0. So if I concatenate two strings of length epsilon, then I'll get epsilon, right? So I should write the rule as S gives epsilon, okay? Because epsilon is the simplest string that is accepted. Okay. Okay. Then for other occurrence of A and B, I should write A, S, B. Okay, so this S can be again further replicated into multiple times as per the value of n, right? So if I want 4 A's followed by 4 B's, then this S has to be derived, or it has to be evaluated to ASB 4 times, and finally the S has to be evaluated to epsilon, right? So this is the rule. For using this rule, I'll be able to generate any string, any valid string for the given language. Okay, so let us consider few examples. Okay, string of what if n is equal to 0. Okay, if n is equal to 0, then string is epsilon. So directly I can derive epsilon using S, right, by applying the rule S gives epsilon, right? So this is obtained. Okay, now what if I take n value as 4, then the string that required to be, or the valid string here will be 4 A's followed by 4 B's. Now how can I obtain this using the rule set what I have for my context-free grammar? First what I will do is I will apply the rule A, S, B, right? So I have generated this A and this B. So these are the two A's what I am talking about. Which rule is applied? S gives A, S, B, right? Now the remaining part, the middle part, has to be obtained by evaluating this S. So what I can do, I can replace this S with again A, S, B, right? So this is the A what I've written here, and this S is rewritten as A, S, B, and followed by this B. So this is what I get. Which rule is applied? A, S, B. Okay, again further I have to evaluate that S to ASB. So this is what I get if I apply the rule ASB. And one more time, these are the three A's what I have, and this S is evaluated to ASB. So I get 4A, S, and followed by 4 B's, right? Okay, the rule applied is S gives ASB. And finally, in my derived string, I shouldn't encounter any non-terminal, so this S has to be removed somehow. So what can I do? I have to evaluate it to epsilon by applying the rule S gives epsilon. So what do I get? 4A followed by 4B. Okay, and this is the valid string or required string as per the value of n, right? And which rule is applied? S gives epsilon. Okay, so I should be able to generate string of any length for this any length in the sense for any valid n value as per the definition of the language. Okay, so this is the required rule. Okay, now let me take a small variation of this problem. What if I change the value of n to 1? So if I change the value of n to 1, here the minimum n value is 1, right? So I should have at least 1a followed by 1b. Okay, so this is the smallest string that is valid as per the definition of the language. So I have to rewrite my grammar. What I need to do is s gives ab. So this is what I'm supposed to write. Instead of epsilon, I should write s gives ab, and the other rule will remain as it is, that is ASB. So this will make sure that I have at least one occurrence of A and one occurrence of B. Okay, so if I can easily generate AA, BB. So if I take this example, then what is the rule applied? ASB. Okay, rule applied is ASB. Then the S can be replaced with AB. So if I replace this S with AB, then I get AA, BB. The rule applied is S gives AB. So this is about language where I have A and Bn, and a value of n is greater than or equal to 1. Okay, so this is the solution for greater than or equal to 1, and this is the value rules for n greater than or equal to 0. Okay, similarly they can this question can be asked with many variations. They can set a value for n with the minimum value. They can give it as n greater than or equal to 3 or 5 or whatever, right? So which can be easily, I mean, with which I should be able to easily make the changes with my original rules to incorporate the value of n, minimum value of n. Okay, so we'll see a few more problems. In this problem, the language L is made up of string W from the alphabet set AB, and the definition says a number of A's, the count of A's in W should be equal to count of B in W. Okay, so here there is only one condition, that is number of A's should match with the number of B's. Okay, a small variation of the previous problem. The previous problem had an additional constraint that all the A's should occur before B, right? So if I remove that constraint, then I'll get then that problem will be converted to this problem, that is equal number of A and B. Okay, so I have to obviously start with the S, non-terminal, and the smallest string again is epsilon, right? So if I have 0 occurrence of A, it matches with 0 occurrence of B, so that should be accepted. So I'll write S gives epsilon. Okay, now what about AB? So here I should have 1A followed by 1B, right? And how can I write a rule for this? Again, it is very simple. What I can write is S gives A, S, B, right? So what happens? For every A, I want a B, right? And A has occurred before B. And this S again can be further evaluated to ASB, or it can be evaluated to epsilon. Okay, if I take any strings, then I can very easily derive this by using this rule, right? Okay. What if the string is BA? So in this case, B has occurred before A, so which is totally valid as per the definition. So I should have one more rule, that is BSA. Okay, now I should be able to generate any string where I encounter B before A, right? Now with this, even I should be able to generate, now whatever the rule I have, I should be able to generate a rule something like this, right? Or a string something like this. So AB followed by BA. So what rule I can apply? Can I apply any rule with the existing rule? I cannot apply, because Of course, this has one A and one B, and this has one B and followed by an A, right? So with the existing rule, I cannot derive this, but this is totally valid as per the definition, right? So I should have one more rule in my grammar, that is SQs SS. Okay. So using this rule, I should be able to generate strings of this kind, isn't it? What I can do, I can evaluate this into one S and the other to other BA to another S, right? Okay. So this is about equal number of A and B. So we shall take a small example, derivation. Okay, so we'll take A, B, A, B, and B. Okay, so will I be able to generate this? This has equal number of A's and B's, right? 3 A's and 3 B's. So what rule I have to apply? The first one is I have to make use of S, Q's, SS, right? Okay. So this first S can be evaluated to, so this is the rule what I have applied, SQs SS. So this first S can be evaluated to ASB. A, S, B, and this is the S what I write as it is. Okay, and this, yeah, so this is the rule what I have applied, ASB. Now this S need to be evaluated to epsilon. If I evaluate that to epsilon, then I'll get AB, yes. S gives epsilon. This is the rule what I have applied. Okay, now make your guess what rule I have to apply here. I have to apply, again I have to apply AB, SS. So S gives SS, right? The first is what I'm doing is leftmost derivation. That is the leftmost non-terminal in the derivation here is evaluated. So this has to be replaced to what do I require next? Again AB. So I will write ASB followed by an S. Which rule is applied? ASB. Okay. So what do I get? AB, A. This is, now I will replace it with epsilon. So I get AB, AB. Yes. This is the rule applied. And yeah, let me write it here. Finally, this has to be replaced to BA. So what I can do, I can apply. So this is what I have, and the S is replaced with BSA, right? So this is the rule applied, BSA. And finally, the S is replaced with, substituted to epsilon. So I get AB, AB, and BA. Rule applied is S gives epsilon. So I was able to successfully derive this string by using the rule set what I have, right? Okay. Now you consider this as a, so how many A's do I have? I have 3 A's followed by A, and 3 followed by 3 B's followed by 2 A. So total number of A is 3 and number of B is also 3. So this take it as an exercise and try to derive the string from the rule set. Okay, let me write this as exercise problem. We'll solve few more problems. In this example, the language L is made up of string W from the alphabet set A, B, C, and the definition says AN concatenated with BN, again further concatenated with CM. Okay, and N is N and M are greater than or equal to 0. Okay, so with this example, I'll also show how it is possible to write a context free grammar for two different sub-languages which is combined together to form a single language, right? If you observe what I'll elaborate what I'm talking about. See, if you observe, this is one language, right? AN, BN, and this is another language. So why I'm taking these two together is there is a relation between A and B. That is it should be equal. It is replicated n number of times. Both A and B. So I should have equal number of A followed by equal number of B. When it comes to CM, it is not related with count of A or B, right? So this is totally independent when compared with the count with respect to A and B. So this I can consider as one sub-language, and this is another sub-language. So what I've done, I've concatenated, or as per the question given, they have concatenated two sub-languages to form a single language. And what we can do is we can write context-free grammar individually for this sub-language, then we can perform the concatenation. Okay. Yeah. So always we again start with S, right? And I should have a non-terminal which is dealing with A and BM. Okay. So let me write it as N. So this non-terminal should be able to deal with equal number of A's and B's. Okay. Then it is concatenated with what? Something that is M, right? Which is independent of N. Okay. N in the sense equal number of A's and B's. So what I will do, I will write another non-terminal C. Okay. So this C is for matching M number of C's. Okay. Or deriving M number of C's. Okay. Okay. So S gives NC. Now for these two individual non-terminal, I have to write a rule. Okay. First one is N. Okay. What I can write rule for N? N is should match equal number of A and B. So as seen in the previous one, what I can do is I can write A, N, B. Okay, and N should match with epsilon. Okay, so this is the rule what we have already seen, right? All the A's coming before B, and this N can be replaced or it can be substituted to epsilon, or it can be further iterated to A and B, right? Yeah, so with this I will be able to generate equal number of A's and B's. Okay, and now I have to write the rules for C. Okay, so C, again it is independent of the count of A and B, so I can simply write it as, yeah, what C gives? C gives a small c, and this C has to be replicated again some number of times. So I will write C, capital letter C. So this is the non-terminal capital, and this is the terminal value. Okay, and finally, of course, this C has to be evaluated to epsilon, right? So this can be written as C gives epsilon. Now there is a question, why it is necessary that I need to write a terminal before a non-terminal. So can it be written as a C gives capital C followed by C? Yes, even this is totally fine. Okay, so if you write your answer in this way, even that is valid. Okay, so this is the answer or this is the context-free grammar for this particular language. Now let us see whether it will be able to generate a valid string. Okay, so I'll take 2A followed by 2B, and I'll take some number of C's. Okay, so I'll take 3 C's. Okay, so will my grammar be able to generate this? Let's check. Okay, so first rule what I apply, obviously it is S gives NC, right? So now what I'm trying to do is I'm trying to derive this. Okay, so what is the rule applied? S gives NC. Okay, now I'm keeping C as it is. Now I am evaluating N. What rule I can apply? A, capital N, B, and C will be written as it is here. So which rule I have applied? N gives A, N, B. Okay, So I need one more A and B. So this N again can be written as A capital letter N E and followed by capital C. A N. Okay, now this N, so I got the two A's and two B's what I wanted. Now what I can do, that N has to be removed, right? So I can evaluate it to epsilon. So this is what I get if I evaluate or if I apply the rule, N gives epsilon. Okay, now I am left with again non-terminal C, so with which I have to derive three C's, right? So this is what I have, 2A followed by 2B's. Now C is replaced with small letter c and a capital letter C. So using this rule, this is the rule what I apply. Okay, which rule is applied? C gives small c, capital C. Okay, then again I'll apply the same rule. I have C. This C is again replaced with C. C gives small c, capital C. Finally, AA, BB, 2C. So one more C I require. Again, I'll replace it with C giving C, capital C. Okay. Now I got the three C what I wanted in my string. Now finally, this non-terminal has to be removed. So I can apply the last rule. Then I get AA, BB, 3 C's what I have. I'll write as it is, and finally the non-terminal is replaced with epsilon. So this is what I get, right, by applying the rule. So I have AA, BB followed by 3 C's. So this is the string what I wanted to derive, and I've obtained it using this grammar, right? So this is how sometimes you have to tackle the problem by seeing it as two sub languages, and you have to write the grammar accordingly.